Okay, welcome back. We're in section 2.3. Now we're going to be talking about another division method called synthetic division. And synthetic division is good when you're dividing by a binomial of degree 1. It only works for a binomial of degree 1. If it's not a binomial, it won't work. If it's not degree 1, won't work. So that's why we had to know long division. Now synthetic division, you can see, and we're going to go to an example because it's going to make a little bit more sense. Now, with synthetic division, we're dividing by x minus 2, a binomial of degree 1. So what we're going to do is we're going to sketch, I call it a box, even though it's more like an L. And on the outside, we're going to set x minus 2 equals 0, and we get x equals 2. 2 goes on the outside. And on the inside, go our coefficients in standard form, largest degree to lowest degree. So we have a coefficient of 6, a negative 19, a 16, and a negative 4. Now, with this, what you're going to do is add the first column, bring down that 6, and now multiply by what's on the outside. 2 times 6 is 12. Then you add the column. Negative 19 plus 12 is negative 7. Now you multiply by the 2 on the outside. 2 times negative 7 is negative 14. When you add, you get a 2. And then 2 times 2 is 4. And when you add, you get a 0. Now with this synthetic division, this was our coefficient for x cubed. At the bottom, it goes down by 1. This is our coefficient for x squared. For x, the constant, and that last number is our remainder. So from our division, we ended up with 6x squared minus 7x plus 2. And that is actually what we ended up with when we divided for problem number 1 on the previous page, or previous couple pages. There's our quotient right there. There's no remainder. Let's do another one. We're dividing by x plus 3. So x plus 3 equals 0. X equals negative 3. So negative 3 goes on the outside. And on the inside are coefficients. X to the 4th, so we have a 1. Now there's no x cubed. We need a 0 for a placeholder. X squared is negative 10. X to the 1st is a negative 2, and our constant is a 4. We need to account for every term. If it's not there, put a 0. Bring down the 1. Negative 3 times 1 is negative 3. Add the column, you get a negative 3. Negative 3 times negative 3 is a positive 9. When you add, you get a negative 1. Negative 3 times negative 1 is positive 3. When you add, you get a 1. Negative 3 times 1 is negative 3. When you add, you get a 1. Now remember, this was our coefficient for x to the 4th, so at the bottom it becomes x cubed, x squared, x constant, and this one has a remainder of 1. So we ended up with our quotient of x cubed minus 3x squared minus x plus 1 plus our remainder, 1 over x plus 3. There's our quotient and remainder. Number 7. We're dividing x to the 4th minus 1 by x plus 1. So on the outside, set x plus 1 equals 0. X equals negative 1. Now on the inside, watch your coefficients. For x to the 4th, it's 1, but there's no x cubed, so we need a 0. There's no x squared, we need a 0. There's no x to the 1st, so we need a 0, and there's the constant of negative 1. So we had a lot of zeros to add there. Bring down the 1. Negative 1 times 1 is negative 1. When you add, you get a negative 1. Multiply by negative 1, you get a 1. Add, you get a 1. Negative 1 times 1 is negative 1. When you add, you get a negative 1. Negative 1 times negative 1 is 1. And when you add, you get a 0. So this was our coefficient for x to the fourth, so x cubed, x squared, x to the first, constant, and remainder of 0. So from our division, we get x cubed minus x squared plus x minus 1 is our quotient. That is long division. Now we can use this long division for what's called the remainder theorem. And what the remainder theorem says is that our remainder is the value of the function at the given value of k. That's the remainder theorem. When you input that value of k, the remainder is going to be what you would get if you evaluated that function. So what we could do for f of x equals, now x equals -2, so at the outside, -2 goes on the outside. Our coefficients go on the inside, same rules as before, 3, 8, 5, and -7. Bring down the 3. -2 times 3 is -6. You add, you get a 2. -2 times 2 is -4. When you add, you get a 1. -2, and when you add, you get a -9. That remainder is our value for f of -2. That's what we get when we evaluate the function. The remainder gives us the value of the function at that given value of x. We'll talk about the factor theorem in our next video. Thank you.